Hello everyone, this is Roger from Wave Computation Technologies. In this tutorial, I'm going to introduce how to apply different types of transient signals in the software Wavenology. To begin with, I want to use this empty project as an example. And first of all, I want to introduce where to view your transient signal. So the first place is in the Design dialog and the Frequency and Pulse tab. So if you have a frequency range, say from 1 GHz to 2 GHz, let's say 0.1 GHz, click Apply, and there's a button over here called Plot Pulse. You click, you'll start to see that this is a signal. Okay, so there's a button over here in the Design dialog that can show your signal. The next place is in the Tree Items. Have excitation pulses. You collapse that, and you will see that all the transient signals here, and then their spectrums are also available. Okay, so that's the second place you can see your excitation pulses. And then the third place is whenever you create a new source. For example, I create a dipole source here. Then there's another button over here, Plot Pulse. You can also see the signal is being used. And in the new pop window, it can show you the waveform. Okay, so that's where you can see your transient signals. The next, I want to introduce how to configure your transient signals in your simulation. So the place that you configured that is in this tab again, Frequency and Pulse. Wavenology has a very nice feature that it only asks the user a very simple input parameter, which is the frequency range. And the software will automatically assign different type of signals based on the frequency range you input. For example, this is from 0.1 to 2 GHz. The pulse is going to look like this. Now if I change it to be 1 to 2 GHz and click Apply, you see there will be a modulated signal added, and the spectrum is guaranteed to be covered from 1 to 2 GHz. Okay, so if I change the frequency again, make it more narrow band, 1.5 to 2, click Apply, you will see this is a transient signal. Then the spectrum is from 1.5 to 2 GHz. Okay, so that's the simple way the user can control their transient signals. If you have advanced knowledge of how to apply different transient signals, you can choose this option, Project Pulse. Okay, Wavenology has a lot of built-in signals that can be used for the user that want to customize their signals. For example, this is BHW Blackman Herring's window function, and we also have Gaussian pulses, Ricker waves. For example, I choose Ricker. First of all, I cancel the modulation, and I choose the parameters to be like this way, and I click Apply. You will see this is transient waveform, and this is the spectrum of this type of signal. Okay, and I also have rectangle signals. Click Apply. You will see this rectangle signal, and its spectrum with this width 1.8 nanoseconds. Its spectrum is from 0 to 0.5 GHz. Now I can also add some of the signals. I can also add modulations. For example, in this rectangle, I add this modulation. I click Apply. You will see there's a modulated signal at this frequency, and this is the spectrum of this type of signal. Okay. So the last one I want to introduce here is the user-defined. In some cases, that the user the transient signal cannot be calculated through analytical formulations. It's either from a measured data or some other user-defined customized signals. So Wavenology has a very nice and convenient feature that allows the user to define their own signal in a text file. The text format is very straightforward. So the first column is just your time at different time steps. Then the second column is the magnitude of your signal associated to each time step. Okay. Now, what I want to emphasize here is the user don't have to worry about their time steps to be exactly matching the d delta t that is going to be used in the simulation. For example, at t equal to 0, your signal is 0, and then at t equal to 1 nanosecond, your signal is 5. Then you can input another data at t equal to 5 nanoseconds. For example, your magnitude is -1 or whatever. So you see that the delta t doesn't have to be canonical, doesn't have to be identical. The software is smart enough to either resample your signal or interpolate your signal. If your signal is oversampled, has a very high resolution, and then the software will automatically readjust the sampling density, and then that is going to be used in the simulation and resample your signal. So this dramatically reduces the pain when users define their own signals. The software can automatically match it in and start the simulation. Okay. Now let's take a look at a example that how I load this file. For example, I click choose file. I have one file here called square signal data. Double click, it will read in. When you click apply, you need to wait for a while because it's doing the FFT simultaneously while reading the data. It tells you that you have 20,000 points of data, and then you can see the transient signal is going to be like this, user defined, and its spectrum looks like this way. And its frequency range is from 0 to 0.05 gigahertz. Okay, so that's all about this how to use different types of functions in the software to adjust your simulations in terms of source signals. The last feature I want to introduce is Wavenology allows different type of sources. For example, plane waves, dipole sources, lumped ports, or wave ports. Okay, even though for the same type of sources, it allows you to define different type of excitation signals in the same simulation. Okay, so first of all, let's go back here to make it still 0.1 to 3 gigahertz and apply that. Let me choose, for example, to be 8 nanosecond. Okay, so this is the empty domain. Now I define a dipole source at this location with Z polarized. Then I want to use my own pulses for this particular source. For example, I enter this to be 0.1 gigahertz to 2 gigahertz. Then I click apply. It warns you that your frequency range is different than what has been defined in a project. But that's okay. The simulation can still run. It's just a warning message. So now I have a dipole source. Now I can define another. Let's shift the location a little bit. I can assign a different pulse. Say, for example, from 1 to 2 gigahertz. Okay, click apply. I warn you again, but that's okay. I understand what I'm doing. Then this is going to be the two sources. Now you see that as you add more sources, there will be more signals added into the excitation pulses. So if you plot all, you will see that all of them are being displayed in the same place. You will see the pulses get narrower, its spectrum is wider. Okay. Now if you modulate your pulse into a centered frequency, you can also see this is modulated as well. Okay. So for example, I have another source, like I add over here, like 2. This place, I use another one. Say I can also use this source pulse advanced features. Okay. Say for example, rectangle, and then I want to make it 0.9. Well, let's say 0.09 nanosecond. Just take a look. It's up to 10 gigahertz. Well, that's too much of my frequency range. So I probably just use 0.3. Okay, it's 3 gigahertz. Okay. So I click OK, and you will see a new signal. So 3 is added right here, and then its spectrum is added as well. So all of them can be simulated together in one simulation simultaneously. Okay, so that's all about how to apply source signals in the Wavenology. Thank you for being my audience.